So now, problem 41. If 144 grams of C5H12 are used with 320 grams of O2, then O2 is the limiting reagent. Okay, my volume's a little too high. Oh.
It's number 44.
Oh, it's number 44. Sorry. Okay, so again, we're going to have to go over to our scratch paper and do a little calculating. And we're going to need information. We're going to milk more information out of the balanced equation. And the beauty of this is I can use any part of, there's many different paths that will give you the same result as far as limiting what's the limiting reagent from the given information. And in this case, I'm just going to ask the following question. If 144 grams of pentane is used, how many moles or how many grams of oxygen would be required to completely burn that? Because this is a combustion reaction. So I'll start over on the left-hand side, and I can approach it from the other point of view. I could have done this starting with oxygen. I can even do it that way. Let's do it that way, just for laughs. It's going to be just as useful. So I'll start over here with 320 grams of O2. Okay? And oxygen is, there is 1 mole of O2 for every 32 grams of O2. Because oxygen has an atomic mass of 16. 16 times 2 is 32. So, you can see where this is going to go. Now, I need to know the mole ratio of the reactants. And it turns out there is 1 mole of C5H12 for every 8 moles of O2. So this is how much pentane is required to completely consume this oxygen. And so if it's completely consumed by this, then that means it's going to be the limiting reagent. The limiting reagent is the one that is completely consumed. The other one, there is going to be an excess. So we're simply asking how much pentane is required to completely consume all of the oxygen present. We could have done it the other way, and it would be the same result. And so now I need to convert from moles of pentane to grams of pentane, and there are 72.15 of pentane for every 1 mole of pentane. Okay, now we've got everything that we need. We just simply have to go through the calculation. We could take advantage of the scientific notation, but I'm not going to in this instance. Or I could. Let's just walk through it and see where we get. 320 divided by 32 is 10. Okay, so I'm going to have to multiply whatever's here by 10. And 72 divided by 8. Sound like any number you've... does that ring any bells? 72 divided by 8 is 9. Okay. So I have here 10 times 9. That's pretty much it. So 10 times 9, and that is, what is 10 times 9? Oh, that would be 90 grams of C5. So it would take, it turns out, 90 grams of pentane to completely consume 320 grams of oxygen. Okay, have we got 90 grams of pentane? Well, it turns out we've got 144 grams of pentane in the given statement. So that means we've got more than enough to consume all the oxygen. There is an excess of pentane, and oxygen is going to limit the amount of product we're going to get. So oxygen is therefore the limiting reagent. And so let's go back over to our problem here. This is a true statement. Okay? And that wraps 41 through 44.